Hello, everyone. When you enrolled this course, you probably didn't expect to deal with any statistics, but surprise, surprise, we are still going to need to cover some basic statistics, basic math in this course. Let me share my screen with you. And the lecture I will cover today is levels of measurement. Why do you think that numbers are important and why do we need numbers in communication? So let's just take a look at some of the examples where numbers play an important role in our everyday life. For example, we will determine how much money we can spend on clothes each month depending on our budget. So we are dealing with numbers here. If we look at vehicles, for instance, they are advertised on the basis of miles per gallon, or this is an example that is closer to you. A student's GPA can predict their success in graduate school. Web advertisers count clicks to measure the effectiveness of their ads. So wherever we look at, we deal with numbers. Now, it is very important to distinguish between numerals and numbers. So what are numerals? Numerals are basically labels. If you look at a plane, for instance, and see Boeing 737, does that really represent a value? No, it is just a label. It is how we call this plane. But also 212 East 86th Street is another label. It's just a street name. It doesn't really represent any value. It doesn't mean that a building with this number 212 is better than a building 211 or 210. So they don't really have any value. They just present labels. Route 21 is also a name of the brand. So it doesn't really represent any value. It's just a label. 10026 area code is another label. Numbers, on the other hand, are different. Numbers are assigned value to some phenomena. Some examples include age, 31, 32, 26. So that is some, that number is assigned, that number actually assigns value to, assign some value. So somebody who is 31 is older than somebody who is 22. So we can make some differences, comparisons, and we can use that numbers to multiply, to divide, and so on. So it does represent some value. Or if we say there are 15 students in class, or there are 0 students in class, these numbers also represent some value. 35 miles, 136 pounds, and so on. So you can see the difference between them and the numbers on, or actually the numerals on the left-hand side. So this is important because it can help us distinguish between among different levels of measurement. In statistics, we deal with several levels of measurement. So we can use nominal measurement. What does nominal measurement represent? So let me give you an example of a survey. You start filling out the survey and they ask you several demographic related questions. Those questions include, what is your gender? What is your biological sex? What is your race? Where are you from? Like select a country where you're from, or what's your area code, and so on. So these are demographic data and they represent nominal measurement. They're just categories. We cannot divide them. We cannot multiply them. These measurements just represent different categories. What some researchers would do, they would, for instance, they would collect data, like they would collect survey data, and they would sometimes just, as they analyze the data, they would sometimes just assign numbers to these categories. So they can assign, let's say, if they are listed, if 10 countries are listed in their surveys, they would assign numbers to countries 1, 2, 3, 4, 5. But those numbers just help them deal with data. They don't really mean that country number 1 is better than country number 2. So they can just use this number to label countries. It doesn't mean that one is better than the other. When it comes to ordinal measurement, that makes a little bit of a difference. because in this case, ordinal measurements indicate that something is better, stronger, or weaker than something or somebody else. So it actually shows the level of progression or rank order. So for example, if we look at the race placement, running race placement, and then there are people who want first, second, third place, and so on. So we have this order. The person who is, we have this rank order, the person who is first, the person who is second, the person who is third, and so on. The same thing applies to class standing. So freshman, sophomore, junior, senior. So you see, you have these levels, and we call that ordinal measurement. Now, a bit advanced measurement is interval. And how is interval measurement different from ordinal measurement and nominal measurement? So interval measurement is a measurement that has equal intervals between points on a scale, but the numbers cannot be divided or multiplied. So for example, one example of the interval scale includes Fahrenheit scale or IQ test. What does it mean? Somebody who has an IQ of 140 is not 2 times smarter than somebody who has an IQ of 70. But if we look at these IQ numbers, 70, 80, 90, 100. So differences, intervals between 70 and 80 are the same as intervals between 80 and 90, 90 and 100, 100 and 110, and so on. So we have equal intervals between these different rankings, but there is no 0 point. So if we look at the Fahrenheit scale, for example, there are equal intervals between 30 degrees and 40 degrees, 40 degrees and 50 degrees, 50 degrees and 60 degrees, but there is no a true zero. Fahrenheit scale includes zero temperature, but temperature of zero doesn't mean true zero. It's not like that we're dealing with the absence of temperature. 0 Fahrenheit is just cold weather. So the temperature is still there. It is just very cold. So there is no absence of temperature. It is just very cold. So there, and we have numbers below 0. But when it comes to ratio measurement, in that case, there's a 0 point, and that 0 point captures the absence of temperature. So for example, ratio measures include that true 0 point. So what does it mean? So if we look at the Kelvin scale, for instance, 0 point means the absence of temperature. So Kelvin scale doesn't have any numbers below 0. 0 is like that, 0 actually represents a true 0. That means no temperature, and then 50 degrees, 60 degrees, 70. So 60 degrees is twice as much, 2 times more than 30, and so on. When you look at other examples of ratio measurement, you can see that there is always this true 0 present in it. One example includes income. So if a person is unemployed, they have 0 income. Somebody who works, I don't know, in trade, let's say, earns $90,000 a year. Somebody who is an account manager, let's say, earns $60,000 a year. So this is ratio level data. Another example is watching television. So if there is a person who doesn't watch television at all, so you can assign a 0 to them. And there are people who watch television 5 hours a day, 2 hours a day, 3 hours a day. So these are all ratio numbers because they can be divided, multiplied, and there's a 0 point involved when we deal with this type of data. Now, how are these measurements different? Nominal and ordinal measures fall into the category of discrete variables, while interval and ratio represent continuous variables. What is it that we could measure? Where can we actually apply these measures? And why is it important that we learn about these numbers if we are doing communication research? Well, let's take a look, for example, the number of followers on Twitter. You want to collect data about different people and the number of followers they have. So you go online and you collect the number. And what kind of data is that when you collect the number of followers on Twitter? What do you think? What kind of data is that? That is ratio, because there could be an account with 0 followers. So you can have from 0 to I don't know how many followers on Twitter. So we're dealing here with ratio level data, and it's easy to collect them because you basically just go to other people's account and collect and look at the number of followers they have, and then you simply create a note on the number of followers that they have. Also, how much time does a person spend on their phone? This is something that could be measured too, but how are you going to measure it? We're also talking about ratio level data, and the way to measure this is basically to ask people perhaps about the time they spend on their phone daily or weekly, and then collect those numbers. But there are more complex constructs to assess with measurements. And one example that I wanted to include here is, let's say you want to measure whether a person is rich or poor, but how do you measure it? Like when you want to assess a certain phenomena and when you want to study it, you want to make sure that you are applying a measurement that is valid, that is actually measuring what it is supposed to measure. So when it comes to this construct, whether somebody is rich or poor, how are you going to assess it? Are you going to ask about the value of their real estate, about their bank balance, about their annual income? If you ask only one question, are you really going to, I do think that you really will be able to explain by that one item whether that person is rich or poor. So I would say that in this case, when you are assessing complex construct, you need to ask several questions. You need to figure out how you're going to measure whether somebody is rich or not. And of course, when you're delivering that, when you collect the data and then when you report that data, you need to explain to us how is it that you measured whether somebody is rich or not. So you explain that in your method section. When you explain how you collect data, some questions about measurement are, what is it that we should measure and record? Does the measure capture what we are interested in? So to go back to that example of whether a person is rich or poor, so if you just ask one question, you're really going to get a sense of whether that person is rich or poor. But if you ask several questions, that you're probably going to capture better that phenomenon that you're interested in, whether the person is rich or not. And finally, can we be sure that our measurements, when repeated, will give the same results? So these are some questions to ask. And there is an answer to that. That answer is reliability and validity. What we do in research, we need to ensure that our measures, the measures that we're applying, are reliable. That means they deliver consistent results over time, and valid. So that means that they are measuring what they're supposed to measure. I'll give you one popular example about the difference between reliability and validity. So let's say you step on a bed scale and your bed scale adds 5 pounds. So you step today and you see that you have 130 pounds. But the truth is that you actually have 125 pounds. So you step on the bed scale the day after, and the bed scale shows 130 pounds again, and then the next day also 130 pounds. So basically, it gives us consistent results every day, but which means that it is reliable. So these results repeat, but it's not accurate. That means the measurement itself is not valid because your bed scale adds 5 pounds. So it can be reliable because it gives us the consistent results, but it doesn't mean that the bed scale is actually valid because it doesn't provide accurate data. It adds 5 pounds. Why is reliability important? So let's say you want to collect survey data. So you want to do survey on the Pleasantville campus, for instance, and you're surveying certain group of people, but to ensure that they're providing honest responses, you can do this test retest method, like give the same survey to the same group of people after 2-3 weeks and see if their answers are consistent with the first time that when you survey them. So that's one of the ways to ensure that there is a reliability, that your measurement will give the same results if you repeat it. Another way to assess reliability, so it is important. Why is reliability important? Because we want to make sure that our data is reliable, that we can stand behind our data and say, this is what we collected, this data really reflects reality. We can make generalizations based on the data collected. We can make some conclusions because what we have is reliable and valid. Some other things that could help you ensure reliability of your measurement is intercoder observer reliability. So that means that if we're looking at people on campus and searching for those wearing hats, for instance, then the number that I see should be equal or close to equal to the number that the other person who is observing the same phenomenon sees. Inter-item reliability, so we can ask individual questions in a question set. So there are different questions that we can ask in a question set to assess something, and they need to capture the same concept. If that concept is, what are you rich? So all the questions should actually capture it, such as some of the questions that we asked in that case were, what's their real estate, what's the value of their real estate, what's the annual income, and so on. And finally, established measure of reliability. You should compare the results obtained from your measure to the results obtained from a known tested measure. So this usually happens when we are, let's say, using a measurement. That is when we are kind of modifying or trying to create a new measurement for to test population in like another country, and then we want to see whether like a different measurement that has been tested already would give us the same results. So we just compare the two and see, and that's how we can establish the reliability of our measurement. When it comes to validity, as I mentioned, it basically means accuracy. It means that your measurement is really reflecting the phenomenon that you're studying. And the measurement there should be conceptual validity. So that entails face validity and expert validity. So the measurement should be valid on its face. It should be evident that the measurement is valid. If you see that somebody is being aggressive, for instance, you're serving a person being aggressive, there could be certain like cues, such as the person is yelling, maybe yelling at other people, or misbehaving, anything like that that would point at that person's aggressiveness. So it should be like evident to other people that what we see is actually really capturing that phenomenon that we want to assess. Expert validity, if people with expertise related to that issue like believe that the measurement is okay, that could contribute to validity. So how do you know whether your measurement is okay? So if you just look at the literature review, if you see what other scholars have to say about the topic that you're studying, then you can back up your measurement with citations from their studies, or perhaps they provided some items that you could use for your measurement. And that is one of the ways for you to validate your measurement. Construct validity, it has to be theoretically supported measurement. Convergent validity, your measurements. So if you're measuring attitudes, for instance, it should agree with similar measurement, like attitudes toward immigrants or attitudes towards refugees. If these measurement agrees, then you can kind of achieve a convergent validity. Divergent is when there's low agreement with different measures, and predictive, when your measure can predict real world outcomes, such as SAT scores can predict your success in college. How do we get to these? How do we establish a measurement? So I will give you an example of scales that you can use to measure something, such as people's attitudes, behavioral patterns, people's perspectives on certain issues, opinions, and everything else that you can measure when you, for instance, want to utilize survey method in your research. So some of the scales that you frequently see in research studies, in surveys, are the semantic differential scale and the Likert scale. So what's the thing with these scales? So they're usually supposed to measure our opinions and attitudes, our feelings towards some issue. And when you open a survey, you will see several questions or several items where you are asked to express your feelings about actually there are statements. You're asked to express feelings about statements. So if you see a set of statements, those statements actually represent your measurement, your scale. So those statements are created to assess, for instance, your attitudes toward social media, or your opinion on current political situation in the US. So they usually ask a list of, they usually list statements and then ask you to express your feelings about it. For instance, one of the measurements could be the semantic differential scale. So how does it look like in a survey? It pairs opposite ideas towards a concept and invites respondents to decide where their opinion lies. So if they ask you to express your opinion about social media, they're going to ask you to say whether social media has positive influence on users or negative influences on users. So if you think that social media has really negative influence on users, you would put an X here. Or if you think it's very positive here, if you think it's negative but not extremely negative, you would probably, your answer will be here, and this position is neutral. And the same thing applies to other items here, whether you want to see whether you perceive social media as friendly or unfriendly, expensive or cheap. So this is based on this semantic differential scale. We can determine what is what are your feelings towards social media? What is your opinion towards social media, negative or positive? Another scale, this is, I believe, even more frequently used in communication research. That is, and you've seen these scales, who knows how many times. So that's the Likert scale. And in this case, for example, you will see multiple statements listed, and then you are supposed to check whether you agree or disagree with them. When we deal with small samples, we usually use a 5-point scale. So 1, 2, 3, 4, 5, from strongly disagree to strongly agree. If we have a bigger sample, like a few thousand people, then we could use a 7-point scale, because that scale makes a greater discrimination. But for smaller samples, such as 100 people, for example, we could use just the 5-point scale. If you look at this scale, so social media are secure, social media are essential, you would just mark whether you strongly disagree, or neutral, agree, or strongly agree. So if people agree or strongly agree with this, our conclusion would be, the majority of our respondents, our conclusion would be that people in general have positive attitude towards social media. They believe that social media are secure and essential, and so on. And one other thing, you will probably use this Likert scale in your research, and why is it, when I talked about reliability and validity, this is actually when you create a scale like this with multiple items and ask people to state their level of agreement with each item, that is your measurement. And with that measurement, by asking several questions related to social media, that you're assessing their opinions or attitudes towards social media. So, and you need to perform reliability and validity tests to make sure that what you're measuring is accurate and that your measurement is also reliable. I'll give you another example. So I worked on this study with my colleague and my friend several years ago. We were very interested in examining attitudes toward refugees from Syria. The attitudes toward refugees, well, how did we assess attitudes? We didn't make up statements because there were measurements out there that already measured the phenomenon that we wanted to assess. So there were scales with items that assessed something similar to attitudes toward refugees. And the scale that we found was a questionnaire on national identity. So we modified the scale a bit to measure attitudes towards Syrian refugees. So this was basically similar to what we wanted, to the measurement that we wanted to design. So we adopted this measurement. And when you're adopting a measurement from somebody else, you just need to make sure that you are going to credit that measurement to that person who created it. We had 8 items in our questionnaire, 8 items that assessed attitudes towards Syrian refugees. So we didn't ask one question. We actually asked 8 questions to make sure that we are really capturing people's attitudes towards Syrian refugees. And we used, because we had a small sample, I think it was about 100 or something students, because we had a small sample, we just used the 5-point Likert scale that range from strongly disagree to strongly agree. Sometimes you will see on this scale, the scales that people start with strongly agree and to strongly disagree, but I really think it's better to just start from strongly agree as like the lowest point to strongly, with strongly disagree as the lowest point to strongly agree. So keep that in mind. Also, the Likert scale is not only strongly disagree, strongly agree, but it's also the scale with items such as very important, not important at all, and so on. So when you see scales that have these intervals, they're basically Likert scales. What kind of statements did we list in this scale? So we modified the measurement that already existed on national identity, and then we created the following items. Refugees from Syria will increase crime rates. Refugees from Syria will generally be good for the United States economy. Refugees from Syria will take jobs away from people who are legal citizens to the United States. So these are some statements. So we asked basically people to state whether they agree or disagree with these statements. And if you see like statements such as refugees from Syria will increase crime rates, refugees from Syria will take jobs away from people who are legal citizens of the United States, these statements are very negative. So if they clicked on strongly agree on these 2 statements, it means that their attitudes towards Syrian refugees are negative. But we really need to we need to look at all the items, and we need to look at like the average and see whether those attitudes are really negative or neutral or positive. So we need to look at all the items. These are other statements that were included in our measurement, and we assess their attitudes towards Syrian refugees. Now, I hope that this lecture was not as complex as statistics and levels of measurement basically appear to be. I just wanted to go over several concepts that we covered in this lecture. And those include the difference between numbers and numerals. So numerals are just labels. Numbers have some real value. And the levels of measurement are nominal, ordinal, interval, and ratio, to make sure that our measurement is capturing what it's supposed to capture and that will provide consistent results over time. We need to assess reliability and validity of that measurement. And some of the scales that we could use to assess people's opinions, their attitudes, are Likert scale and the semantic differential scale. Now, I have an exercise for you. What I want you to do is to look at all these examples of different levels of measurement and look at these variables listed on this slide. And for each variable, figure out which level of measurement that is. Is this variable nominal? Is this variable nominal, ordinal, ratio, or interval? Is weight nominal, ordinal, ratio, or interval? What about race, school ranking? So for each variable, just add a dash and just assign like a category level of measurement for that particular item. So you need to do this for each variable listed here, and then you will post your answers under levels of measurement. I hope this is clear. You will find further explanation in the textbook, and you can also learn more about levels of measurement online. There are many statistical websites that provide some other examples, but even examples in this lecture should be helpful. This is my reference list, and thank you very much for your attention. I hope this was not very difficult. So I really encourage you to start working on some basic statistics, because it will help you collect interesting data. It will help you with your data analysis, because this data that you collect and the tests that you can use later to analyze data could help you make some predictions and really come to some interesting analysis about the phenomenon that you want to research. If you have any other questions about statistics, just send me an email and I'll be happy to answer. Have a great week. Bye-bye.